The United States manufacturing base is continually faced with cost pressure as a result of rising costs of raw material, energy, labor, and benefits. As a result, companies need to become smarter and more resourceful on how they provide solutions to manufactured products to remain competitive. Applying automation in manufacturing is one method of reducing long-term operational costs. But many times, this type of modernization requires custom interfaces and software to be developed, which can be very intimidating to a small or medium-sized manufacturer.
When we participate in an automation effort, the biggest challenge that we face is establishing communication between the devices. Most robotic and machine manufacturers use their own proprietary package and do not offer off-the-shelf interfaces to other manufacturers' equipment. Therefore, we have to invest the time and effort to integrate disharmonious components, which many times is a one-off solution and that cannot be used for other automation efforts. We feel that a simpler and more unified method of communication for the device integration would go a long way in helping to decrease the overall cost and the expertise required to automate manufacturing work cells.
The robot-controlled integration enhancements using ROS-Industrial and MTConnect program investigated the reduction in automation integration costs by utilizing the software protocol MTConnect and the ROS robot operating system to enable facility-level interoperability between machine tools and robotics, as well as ease in programming robotic movements. The effort was sponsored by the National Institute of Standards and Technology and managed by the National Center for Defense Manufacturing and Machining, partnering with System Insights, Southwest Research Institute, and AMT, the Association for Manufacturing Technology. MTConnect is a set of open, royalty-free standards intended to foster greater interoperability between manufacturing equipment and software applications by making data available over networks using the Common Internet Protocols. ROS-Industrial is an open-source BSD license program that contains libraries, tools, and drivers for industrial hardware. One of the goals of the ROS-Industrial library is to allow the development of advanced functionality and capabilities in a vendor-independent manner, while still utilizing vendor hardware for safety and reliability.
At the beginning of the program, we conducted a survey of small and medium-sized manufacturers. We were really trying to understand from these manufacturers what challenges they face on a daily basis when they try to introduce automation into their factory. Interestingly, we found a number of key points continue to surface among all the small and medium manufacturers that we surveyed. Number one, when integrating multiple pieces of equipment together, it's very hard for the small and medium-sized manufacturer to justify the return on investment. The upfront cost can be very high and very difficult to justify. We found that these costs can easily range anywhere from 2 times to 5 times the hardware cost, depending on the level of integration that was being introduced into their factory. Number two, the communication between the devices is always very difficult. Multiple pieces of equipment speak various languages. Tying these pieces of equipment together is definitely a challenge for the small and medium-sized manufacturer. Many times they have to rely on outside integrators, which can be very time-consuming and costly. Third, what we found was when they did introduce automation into their factory, it was always a custom one-off solution. The only thing that could be reused was the experience itself. Anytime they took on a new automation program, they had to reintroduce new software to get other pieces of equipment to successfully talk and integrate. And finally, the technology itself can be very intimidating to a small and medium-sized manufacturer. Many times they lack the internal technical resources to take on the project, and the overall lack of plug-and-play software solutions that are on the market can be very intimidating.
So, the goals for this project were to gain a more thorough understanding of the advantages of linking ROS-Industrial and MTConnect for advancing interoperability of robots and their associated payloads, to identify the industrial uses of specific applications that can take advantage of interfacing these standards, to develop a common framework for robot manufacturers and users to allow for more rapid integration and lower-cost manufacturing automation, and to conduct a proof-of-concept demonstration showing the integration of ROS-Industrial and MTConnect.
As part of the MTConnect standard, we identified tasks that a robot must perform in order to interact with a CNC machine. We then program these tasks at the ROS-Industrial level, thus removing the need to do any program on the robot controller itself. As with any physical robot setup, it's always different depending on the application, and thus the robot motion has to be recorded and performed for each individual application, but this is done using an industry standard teach-pendant approach. Teach-pendant programming is a way of moving the robot and recording those waypoints that are later played back as part of the robot program.
The systems architecture used in the MTConnect ROS-Industrial demonstration had NIST made use of the MTConnect read-only communication strategy, where devices do not directly control each other. They publish their state using an HTTP server, and the other devices perform actions if they are capable to do so. In the demonstration, we use a robot and a machine tool. The machine tool does not send messages to the robot. The machine tool requests data from the robot, and the robot from the machine tool. For example, when the robot changes its open door state to active, the machine tool responds by transitioning its open door state to active. Once the door is open, the machine transitions to complete, and the robot acknowledges by transitioning back to ready. The roles are reversed when the machine tool makes its load material request from the robot. This is peer-to-peer communication. The benefits of this architecture are the ability to scale from a single device to multiple devices, even different types of devices. When new devices are added, communication between devices is identical to the one-to-one scenario. This architecture easily extends support of many-to-many communications, which enables fault-tolerant processes that are driven by demand and availability, not a preset sequence of operations.
The project demonstrated the successful ability to utilize MTConnect and ROS-Industrial for cell applications utilizing machine tools and robot systems. The process for robot-machine tool integration, as developed under this program, will likely require future enhancements before it can be considered a standard for real-world applications. The program showed that the use of open source standards and software can be utilized in automated systems, thus providing the advantage of being readily available to any size company. Many free and open projects have been started in the past and failed. MTConnect and ROS are different since both have the advantage of being well supported and backed by stable organizations with long-term outlooks. For more information on MTConnect, visit mtconnect.org, and for more information on ROS-Industrial, visit rosindustrial.org.